So very good morning to everyone. So it is good to sit together, not like a scattered manner. So I can concentrate on you also. Please come to this side. So everyone, please occupy these 2 rows because our strength is also little only. You come this here. Okay, so of course the subject is already introduced. So subject is already introduced in the first class. This is second class. So but at the time, who are there? Can you please raise your hands? 1, 2, 3, 4. 4 members are there in the first class. But PPT at the time PPT is not working. That's the reason. I'll just go through the whatever we discussed. Okay. So this is the subject name is the chemical and process thermodynamics. Chemical and process thermodynamics, mostly thermodynamics. You may heard, I think, many in disciplines. I don't know. But thermodynamics is a very common subject to all the engineering branches. Mechanical engineering, triple electrical and electronics, ECE, and also civil, biotechnology. What else? Chemical, obviously. Biomedical, I already told. What else? Any other? What are the other branches are there? Oh, CSE. Maybe CSE they don't use the thermodynamics. IT CSE, aligned branches CSE, they may not use the thermodynamics subject because that may not helpful to them. Apart from them, and this subject is useful to everyone. Means what is the meaning of that? Means everyone deal with this subject because that subject will helpful to design their own engineering. Because we are pharmaceutical engineers. What is our objective? As a pharmaceutical engineer, what is your objective? To prepare a drug. No, it is not our objective. We prepare a drug in a bulk in industries. So we try to design the pharmaceutical industry, complete industry we try to design. This is our goal. Okay, from the raw material to the end product. Okay, from the raw material to end product, how the two raw material has to mix. After that, what is the reaction? How it will be separated? After chemical reaction is formed, some byproducts are there. How can you purify them? How can you convert into the packets and everything from the beginning to the end? As a pharmaceutical engineer, you design the process. Okay, how should go? For example. For a simple example, everyone, preparation of tea now, everyone their own recipe. So, for example, particular person, they add all the ingredients together like a water, milk, tea powder, sugar at a time and they will eat. That is the one recipe. Another one, first they will add water, after that tea powder, so that will be boiled. When it is boiled, then milk is added, after that sugar is added. Some other people, the ginger will be added, elaichi will be added. Means this is a process. Adding together is a process. Adding one by one is a process. In industry, how should we add together? How should go together? Okay. So this is the industry. As a pharmaceutical engineer, your aim is to how to design the process. So tea preparation design is, for example, one is design. Add together, it will come taste like this. And add like this, and the taste will come another way. So, as a pharmaceutical engineer, how can I design some in pharmaceutical industry so that the drug cost minimized. Okay. For example, in the tea preparation, if we are adding together, maybe the gas, the cost is maybe less. So means economically you are reducing the money. Okay. So what process it will help you? You are studying the pharmaceutical engineering, because how can I design such a process so that the cost is reduced. Okay, and also not only that, not only the process, we design the equipment also. What type of equipment should I choose? In the same example, for preparation of tea, what type of vessel should I choose? Should be it is like a very big bowl, a very small glass, or which one is appropriate? Based on our product, how many members we are preparing. Based on that, we have to choose. For example, you are choosing very thick size bowl, then the heat will be wasted. It's not good suitable to preparation of tea. Maybe it will be useful for biryani, I think. So, but if you are choosing very thin, then it is also may not be suitable. Because when the bowl is heated, because of the heating the bowl, when the bowl is heating up, because very thin, it may give some jerks. You may heard. So because while for example very thin bowl is there, we are immediately heating, then we will heat it up and will expand because of the expansion coefficient. Will expand when you put the water immediately. What will happen?
Blast.
Water will blast. So these are some reasons. So means what type of vessel I should choose? What type of in pharmaceutical industry for mixing purpose to raw material, to mix the two raw material, how to choose one vessel? How should be mixing? Hesitator is there. Hesitator, how should be? What is the design of the hesitator? How should be? So that I can get the perfect mixing. After that, what is the reaction size? Reactor size? What are the heat exchangers should I use? Okay. So after that, how to separate them? For example, after preparation of tea, what you do? You will separate with using the unit operation is there in that. What is the unit operation in that? Filtration. That is a unit operation. Use the filtration. Like here in a pharmaceutical industry also. What is the unit operation? It is appropriate to separate my product from the byproducts. Okay. So means these are the as a pharmaceutical engineer, this is your aim, to design the process. Not only that, to design the equipments. Okay, so that your knowledge is helpful to design the process of particular drug and also equipment, so that you are directly encouraging, helping the society to reduce the drug cost. That is your aim. It's a great aim. In the first year I came to you, so I asked you what is the objective of pharmaceutical engineering. Do you remember?
Yes.
So you told somebody. Ramesh also told. I remember. He told in Telugu, but he explained. I remember still. So means that is your object. You are studying every subject with that goal. Okay, I need to design a process, the low cost process, and also equipment's low cost equipment, so that it will give you the best products, good products, quality products, quantitatively good products, so that the cost is reduced, and so that we can serve the drug to the people in a affordable cost. So that is your object. Very great responsibilities are there on your shoulders. So please study and know the subject well. Okay. Now this subject is also helpful to design the process and design the equipments. Okay. So we have already seen the objectives of this course, the CPT, Chemical and Process Thermodynamics objectives we have already seen, so that we will discuss, even though you are not attended. But so next one, these are the briefly I will go. First in the first unit we will discuss the fundamentals of thermodynamics. Okay. So fundamentals of thermodynamics. What are the theme? What is the work? first objective is the fundamentals of thermodynamics, like what is the heat, what is the work, what is the first law of thermodynamics, what is the second law of thermodynamics. Okay. So what is the second objective is understand the pure compounds, means single compound. For example, oxygen is a single compound, hydrogen is a single compound, water is a single compound. Like pure fluids, that's called pure means single fluids. Properties, what are the properties? And what is the correlation? Property correlations. Property correlations, when the temperature is changing, how the density is changing. We don't need to do every time the experiment to determine the, for example, at room temperature, I know the water density. What is the water density at room temperature? Around 1 kg per meter cube. 1000 kg per meter cube, 1 centigram per centigram. So, but if I want to increase the temperature, what is the density? Do I need to do experiment? No. Thermodynamics will help you to determine and to develop the correlations. Okay. So because by using these correlations, you can easily, without doing any experiment, you can easily know the what is the when the temperature something is changing in the pure system, how the other property changes. That is called the property correlations. Okay. So in the third unit, same thing, property correlation, property, but mixtures. That's the only difference. Okay. In the fourth unit, phase equilibrium. Okay. So fifth unit is the chemical reaction equilibrium. Very simple subject. For first one is the basic thermodynamic properties. Second one is the pure compounds properties and their correlations. Third one, mixtures, properties and correlations. Fourth one is the phase equilibrium. So what are the laws are there to determine the phase equilibrium, and also chemical reaction equilibrium in the fifth unit. So homogeneous and heterogeneous reactions are there. In that reaction, what is the chemical reaction equilibrium? How to determine it? What are the laws? What are the laws are there to determine them? So these are the 5 objectives. Okay. In these 5 objectives, these are the outcomes. Means after first unit, you are able to understand all the fundamentals of thermodynamics. Okay. If you are not able to understand the fundamentals of thermodynamics, then somewhere you are not studying properly, maybe you are not listening properly, maybe I am not teaching properly. So that somewhere is a problem that has to be rectified. Okay. So these things are already I have gone through, so that I can discuss. So the next one is the mapping. So mapping means this subject, how it is helpful to the P means PO means do you know anyone program outcomes? BTech Pharmaceutical Engineering is a program. Okay. Generally engineering for everyone has a 12. This 12 PO means program outcomes. Program means BTech is your program. For BTech, so 12 outcomes must be there after graduation. Otherwise, you are not graduated student from the BTech. Okay. So this course will help you to gain those outcomes. So after graduation from the final year, so like what is the first outcome? Do you know anyone? So what? Then why are you studying then? What without goals? So there are 12 outcomes are there. Every register there are there, and also in your syllabus. Your syllabus is there, na? So these are the 12 program outcomes. Means first outcome is saying engineering knowledge. So every course is designed to give the engineering knowledge. Engineering means here is design. Okay, designing something. For example, pharmaceutical engineering, designing the process, designing the reactor. When you say that designing the reactor means what? What is the size? What is the diameter? What is the thickness? How should be the structure? What is the structure of that vessel? What is the structure of the equipment? So these are the designing. Okay. For example, in a mechanical engineering, how to design the engine, how to design the one automobile vehicle. So how to design the something like that related to the mechanical system. So in triply designing of electricity, how to transfer the electricity from one place to another place in a proper manner, like how to design the transformer so that it is effective, how to design the what else, what are the things are related to the electricity. Civil department, how to design the building, how to design the roads, how to design the construction, how to design the what else? So these are all related to bridges, they are all related to the them. So means design is every subject. For example, in engineering, in engineering branch, pharmaceutical engineering, these subjects will also give the 3 means maximum, means basic engineering knowledge it gives, means designing of something it gives. Second one is the PO2, means the CO1 is the first we discussed the CO1 means course outcome, means unit 1. What is the outcome is, what is the unit 1 outcome here? You are able to, after completion of the first unit, you are able to understand all the fundamentals of the thermodynamics. So that will, that thing, so will help you to the basic engineering knowledge. Second one is the program analysis, problem analysis. How to analyze the problem. Any problem is there. For example, this room is heating up, too much heating up. How can I design this room so that the ventilation is very good, so that always I can maintain the room temperature? Okay. So these, the fundamentals of thermodynamics will help you to the problem analysis. There is a problem in your home. Problem is there. What is the problem? So gas is leaking. So your cylinder gas is leaking. How to? So of course the technician also know that, but as an engineer, how can you rectify that? How to design that so that cannot be leaked anymore. So problem analysis and then design and development of solutions. Not only that, not only when the problem comes, we are going, this first unit, for example, the first outcome, when the problem comes, we don't not only solve, second the objective is that we will develop some solutions, future solutions. So that will also will help. And PO4 is the conduct investigation of complex problems. Any complex problems are there. So how to investigate the complex problems? This CO1 will help you. The 2 means average. Next 5. Fifth one is the modern tool usage. Any modern tool is there in a recent according to the based on the recent technology. Any modern tool came. So this unit 1 also will help you to handle those tools up to some mark. Okay. Next one, 6th one is the engineering and society. How to design, how to society. So between the connection between these. Next 7 is the environmental and sustainability. Any environmental problems are there and sustainability problems are there. How to solve them. Okay. PO8 is the ethics. Maybe course may not directly help you to know what are the ethics. Okay. Next PO9 is the individual and teamwork. So actually this has to be one. Teamwork, it will also will help you to do some certain teamwork tasks. Next PO10 is the communication. PO11 is the project management and finance, somewhat, and PO12 is the lifelong learning. This subject will help you for lifelong. So wherever I go, wherever I do any other work, for example, someone will do core work, core related job, or someone will do software related job, or someone will do research related, or someone will do MBA related, management related. Wherever you go, this subject will help you. So like the lifelong learning is yes, this is true. Yeah. So this is the 3 means maximum. So like for every means in this unit, in this subject, what 5 units are will help you to your program, that is your BTech somewhere. So So means this subject will help you to equip as a BTech graduate student. Whatever the BTech graduate student is needed to show that I am a BTech graduate student. So somewhat it will help you. Okay. So these are the mapping between the course outcomes and the program outcomes. Okay. So please write these textbooks. I think last class we has not attended. So everyone are maintaining separate notebook now. Anyone doesn't have the notebook? Everyone has na? Last one? Okay. Please write this textbook name. So please refer these. Please refer them. First one is a J dot M dot Smith. So if we are completed, we move on to next step. So these are the foreign author textbook and this is the Indian author textbook. Both refer both. It will really helpful to you. Okay. Yeah, completed. So J dot M dot Smith and H dot C dot Ramnes. The book name is Introduction to Chemical Engineering Thermodynamics. Up to that is sufficient. Next, second book name is the K dot V, K.V. Narayanan. The textbook name is a textbook for Chemical Engineering Thermodynamics. Okay, this is the textbook title. The author name is the K.V. Narayanan. Okay. Okay. Now we discuss the what is introduction to the subject. First we discuss the introduction to the course. Now that one we discuss. Second one, introduction to this subject, thermodynamics. Introduction to the thermodynamics. Now, okay. Actually, this thermodynamics was born in the 19th century. Okay. Why it was born? Do you know anyone? Do you know this? What is this?
Steam engine.
Steam engine. Actually, before before the thermodynamics, actually there was already the steam engine was invented, and now because using the steam engine. So you know the steam engine. What is the use of steam engine? Steam engine means using the steam. One by one,
Using the steam, the engine will run.
Engine will run. Very good. What is the engine? What is the engine?
It converts somewhat energy to another energy.
Yeah. What is that somewhat energy to another energy?
Heat energy to mechanical energy.
Excellent. So heat energy machine is the engine is a device. It converts the energy, any type of energy into mechanical energy. Okay. So any type means here is a heat energy. Steam gives the heat energy. That energy this engine converts into the mechanical energy. Okay. So at the time it was already invented the steam engine. Using the steam engine, the wheel is rotating. Locomotive motion is started. Locomotive means reputational motion. So started. So but they want to increase the efficiency of this device, this engine. So then they are studying and doing the research, and they found in that research they developed some science. That science is called thermodynamics. So the science is built on the basics of 4 laws. Okay, these science, actually they already the steam engine was there. They want to develop the steam engine performance, efficiency. They want to increase. So they started studying the to increase the how to increase the efficiency of steam engine. Then they developed some science. That science is called thermodynamics. Okay, this thermodynamic science is developed based on the 4 laws. Please write. 0th law of thermodynamics, first law of thermodynamics, second law of thermodynamics, and third law of thermodynamics. Zeroth law of thermodynamics, first law of thermodynamics, second law of thermodynamics, and third law of thermodynamics. Okay. So I will call him. What is your good name? Praveen. Praveen, do you know first law of thermodynamics? What is the first law of thermodynamics? Energy cannot be created, cannot be destroyed. What else? The full statement is that only? Okay. So next one, good name, your good name? Nitin. So what do you know? This first law of thermodynamics? Yes. Your good name? Farina? Ifra. So Ifra, yesterday I told you, because your friend also doesn't have that much knowledge. You are asking them, that is the way. So you can ask me, because I am little more better than your friends. Okay? I can clarify you. So even though you are discussing with them, nothing will be fine. No fruitfulness. Okay? Please, you can discuss with me. Yeah. So what do you call other name? Do you know any other name? This first law of thermodynamics is also called with another name. Do you know anything like that? Anyone knows? Law of conservation of energy. So law of conservation of energy. The first law of thermodynamics is also known as law of conservation of energy. Not energy. So do you know the full statement? Praveen said some partial statement. Full statement. Do you know? Okay, very good. So it can be converted into one form to another form. Very good. Yes, please sit. Both of you. Next one. Second law of thermodynamics. Do you know? You don't know. Anyone knows second law of thermodynamics? 0th law of thermodynamics? Yeah, please tell somebody. Yes, last one.
If A and B are in contact, if they are both the same temperature, if B and C are in contact, then A and C are at equilibrium.
No, they are not understood.
If A and B are in contact, if they are in equilibrium.
Okay.
If B and C are in contact,
Yes.
they are equilibrium. Then A and C are both at equilibrium.
In equilibrium in temperature. Very good. Nice. So for example, so A and B are in the same temperature, equilibrium in a temperature, A and B, and also B and C are in equilibrium temperature, then C and A also equilibrium in a temperature, and anything. Okay? So that is the 0th law of thermodynamics. Third law of thermodynamics, anyone knows?
Entropy is equals to 0.
Excellent. Entropy is equal to 0. But what are the conditions? Correct only? Do you know anything like that? No. Yes. So means at 0 Kelvin, the entropy is 0. Not 0, constant. The second law of thermodynamics says the entropy for any isolated system, the entropy continuously increases with the time. For any system you take, in the universe, any system you take, the entropy continuously increases with the time. But third law of thermodynamics says at 0th Kelvin it is possible, it cannot increase. I will tell you. So the laws are there, we are going to discuss one by one. So please write the first law of thermodynamics. It is also known as law of conservation of energy. Please write. It is also known as 2 marks questions. It must be asked because it's a fundamental thing you need for your lifelong. So it is every mid one it is asked, the mid two may not asked because unit 1 is not there, and in the end exam it will be asked. There is no doubt in that. So please you will, if you know it, you are already secured 2 marks in your pocket. Okay. So not for the marks sake, but know the subject sake. It's a very good subject. So you can do much more things at your home also. Okay, so it is also known as law of conservation of energy. The total energy for the statement is the total energy of an isolated system remains constant over time. Second law of thermodynamics says with the over time it is increases. But first law of thermodynamics says the total energy of any particular system is constant. So energy cannot be created or destroyed in an isolated system. Instead, it can only change form from one part of the system to another. It can only change the forms, different forms, from one part of the system to another. Okay, done? Okay, then I forgot your name. Sangeeta. So Sangeeta, their fan is rotating. There is some energy is created. So what is that energy? Electric. No, now the energy is created, not electrical energy. Mechanical. But you will see one energy. What is that energy? You will experience that.
Wind energy.
Wind energy. So wind energy is created. So we cannot say created. It is converted from where? Electric energy to mechanical energy to energy. So okay. So means the energy, now we cannot say wind energy is created. Just wind energy is converted from other forms of energy. Okay, please see. So this is the first law of thermodynamics. Next one, second law of thermodynamics. The second law of thermodynamics states that, please write, the second law of thermodynamics states that the total entropy of an isolated system, the total entropy of an isolated system always increases over time. Okay. The second point is, what is the entropy? Entropy is a measure of disorder or randomness of the system. Entropy is a measure of disorder or randomness of the system. Okay, so we will discuss that. First, please write first. This law also suggests that heat will spontaneously flow from region of high temperature to region of low temperature, and it is impossible to convert heat completely into work with 100% efficiency in a cyclic process. In a cyclic process. Efficiency in a cyclic process. Okay, so what is the first statement? I believe you completed. Completed everyone? Anyone still writing? Completed? Everyone completed? Okay, what is the first class says? Second class says? The second class says the any isolated system, you take any isolated system, with increase in the time, what will happen? The entropy increases. What is the entropy? Disorderness. System disorderness. What is the disorderness? Huh? What is the disorderness?
Heat or energy.
Change in heat energy is a disorder. Is it disorder?
Random molecules.
Movement of
Molecules of particles.
initially, for example, initially in the system, the molecules, for example, if you take the tree leaves are in the same, there is order. When they are falling from the tree branches to the ground, will they maintain same order? So they will fall in a disorder, randomness. So means the thermodynamics, second law of thermodynamics says, so means leaving the branches from there to reaching to the ground is a very easy process, because the randomness is increasing, the entropy is increasing, so that this process gaining very easy. Compared to that, leaves are there on the ground. Now every leaf is coming back and attaching to the same place. Now disorderness is decreasing, means orderness is increasing now, because leaves are there on the ground randomly. Now every leaf has to go in an orderly manner to stick to the branch. Means what is happening there in the reverse, in this process, orderness is increasing. When the orderness is increasing, the thermodynamics says this process is very difficult to gain. Okay? For example, I already told in the first class. For example, glass is there, glass beaker is there. So when I just drop that glass onto the ground, then it was broken. Okay? Means, so order, because of the broken glass pieces are randomly scattered everywhere. But every piece coming together and bringing again forming like a glass and coming back to my hand is very difficult, because the orderness is very high. When the randomness is more, that process is very easy to gain, to achieve, so that you go that direction where it takes very little energy to gain. For example, C plus O2 is equal to CO2. This reaction is very easy because there in the microscopically randomness is very, very high. That's the reason you are getting C plus O2 is equal to CO2. Okay. Why not? Why always C plus O2 CO2? Why not other way, like some other way? For example, what you can say, some other compound. Why are not getting that? Because of the disorder. Means, for example, ice cream case, glass case. Because falling glass falling on the ground and breaking into pieces is very, because the pieces are spreading over the spreading easily over the scattered places. That is the very means the randomness is increasing with the time, but coming back process is it is also possible. It is not, we cannot say impossible. Every process is possible, but very difficult to achieve. That's the only thing. Okay, so that's the reason. So this thermodynamics, second law of thermodynamics says why this process is very easy. Why not this process is very not easy. So it says because it determines what is the randomness from this process to this state to that. So if the randomness is increasing abruptly, then it says that this process is very. For example, you take the water you are heating up. What will happen next to vapor is converted. From the vapor still you are heating up, plasma is created. Okay. So the reverse process. So for example, you are heating down, reducing the temperature, the liquid is converted into the solid state. Okay. So means from the converting the water into the gas is easy, converting the water into the solid is easy. Which one is easy?
Water into gas.
So this thermodynamics will tell which one has from year to year orderness is increasing or year to year orderness is increasing, or randomness is increasing year to year, so that it is very easy, or randomness is increasing from the liquid to solid. So which one that will tell. The thermodynamics says this means randomness is this. Okay, means it is the molecules in a microscopical is very complex topic. This is entropy. It's very difficult to understand also. A simple word this is. Okay. So in a molecular scale, the molecules are arranged in a particular manner, but for every time the orderness means randomness is increasing. Okay. So that is the entropy says. Means in every system, microbiological system, with the time progressing, the randomness will increase. Means entropies will increase. Okay. So along with that, two more statements are there into the second law of thermodynamics. First one says, no process is possible. No process is possible that can convert the 100% heat energy to the 100% work energy. Okay, and no device is there that can raise the temperature from the low energy to the high energy. Okay, that is the mean. These two statements you can also see in other words. For example, first one says the heat will flow from a high temperature to low temperature. So means no process is there that process will raise the low temperature to high temperature. The temperature flowing from the low to high, there is no such process like that. Always temperature flow from high to low only. So another one, no device is there that can convert the 100% heat energy into work energy. Until now, no one has invented. So there are losses. For example, some amount of heat energy you have taken, only some amount of energy only converted into the work. You cannot convert 100%. So means there is no device and there is no process. There is no process means the process is the heat will flow from the low temperature to high temperature. No process such a way that, and no device also. So this is the second law of thermodynamics. Next one, after the first law of thermodynamics, second law of thermodynamics, zeroth law of thermodynamics was invented. That's the reason. So it is named as zero, because even though it is coming in the first place, but they already invented first and second. That's the reason they have given the zero. So please write this one, the zeroth law of thermodynamics. The zeroth law of thermodynamics says that if two systems are in zeroth law of thermodynamics says that state that if two systems are in thermal equilibrium, with a third system, then they are in a thermal equilibrium with each other. Okay, so you can also write this one. If two systems are at same temperature as the third system, then they are the same temperature as each other. So you already know this, so I don't want to discuss this. So completed? Shall we move on to next slide? Next slide. Then moving. Is okay now? Completed everyone? Yes. The next one, third law of thermodynamics. Third law of thermodynamics says the entropy, any isolated system entropy approaches to minimum value are constant at a absolute zero temperature. Absolute zero Kelvin temperature. The third law of thermodynamics. The third law of thermodynamics says that as the temperature of a system approaches absolute zero, means 0 Kelvin, the entropy of the system approaches a minimum value. Approaches a minimum value. Approaches minimum value. So what is this image shows? At the temperature is greater than 0 Kelvin, the molecules are in a randomly rotating. But when it is equal to 0, so they are more or less stable and there are no motion in the molecules. Okay, then there is no randomness. It increases with time. Randomness is not increasing with the time means entropy is not increasing with the time. Okay, so this is the third law of thermodynamics. Completed? So this is the science. Based on these four laws, the steam engine efficiency and performance was increased. Okay, so means the thermodynamics was born to establish the steam engine performance. Okay, but for us, how it is helpful? For us, why do we need to study? Because we don't study steam engines. We don't study. Now, how it is helpful to us? Please don't write. Please tell me first. Based on this knowledge, please tell me first. Maybe you already see the point. Okay. So how it will helpful? First point. To reduce the heat loss. Reduce the heat loss. Thermodynamics will help. Very good. I try to want to get the answer from everyone from here. How it will? Any just vague idea? Do you have any vague idea? How this thermodynamics will help our pharmaceutical engineers? We are pharmaceutical engineers, na? We try to design the equipment. We try to design the process. How this subject will help to design the process, design the equipment? You can change it. I mean, heat transfer. Heat transfer subject will help you. Thermodynamics will help you. To increase the efficiency of the process, thermodynamics help. So increase the efficiency of what? For reducing the heat. No, as a pharmaceutical engineer, where it is helpful? Increasing the efficiency. Where?
So we have boilers and
boilers. So boilers efficiency can be studied by the heat transfer only. Boilers efficiency can be increased by heat transfer. Subject you already studied. Studied or studying? Study. Oh, you are going to study how to increase the boiler's efficiency. For thermodynamics, To maintain constant increase in energy, not desired one. Sometimes it is desired one, but most of the time it is not desired one. Maintaining the equilibrium, because chemical reaction won't take place, products won't form. If the reaction is A plus B, B stays to C plus D. If there are reached into equilibrium, no A plus D converted into C plus D, no products are forming, because C plus D already they want to come back to the reverse manner. Okay. So means where will there are, for example, as a pharmaceutical engineer, you want to do some mixing. How much energy is required to do this mixing work? Okay, mean it will calculate the amount of energy, how much energy you require to do this much work, how much material you are taking, how much mixing you want, how much mixing you want, then how much work you require to get. Not only that, for example, in a pharmaceutical industry, so many mixing are there, and also you want to transfer the one material to another place through the pipes. For example, water you want to send one place to another place. How much work energy you require to transfer from one place to another place? How much you need? So that will be determined in the thermodynamics. How much horsepower pump you require to send this fluid from place to another place? You cannot choose randomly, na? For example, you are transferring the honey from the one place to another place, because honey is like so many companies are there. Safola, Dabur, they are preparing the honey. So means they want to transfer one place to another place to into the bottle. So how much horsepower pump must I use so that it can be transferred from one place to another place, because it is a very viscous material. I cannot choose some pump so that it will be transferred. I cannot purchase, because transferring means I go to shop, so I will use 2 minutes, I will check it, if it don't work I will leave it. I cannot say like that, I need to purchase. So how much energy power I need to choose? How can I do that? How can you know that? So I need to first calculate what is the what is the distance I need to do, what is the material viscosity, what are the material properties. Then from there I can determine yes, this much energy is required to transfer from this place to this place, so that much energy pump I can procure. Okay, so means as a pharmaceutical engineer, for do any task, you take mixing, transferring, filtering, whatever you take task, the thermodynamics will help you to determine how much work energy required to do particular task. So that's the reason this point is not only pharmaceutical, everywhere. For example, mechanical engineering people, how much heat energy required from the to do this particular task. Task means I want to move from here to here. So how much energy I required. So means they also need it. Civil engineering people, they need it because I want to construct the building. How much energy it can sustain. So like Ghibli people. So like for everyone is required, because the first statement. That's our first statement is this one. Determine the amount of heat required for the process. So because of this first point, pharmaceutical engineering, for our own particular reasons, we need to use this thermodynamics to determine how much work energy I require. Okay. The second point, please write, determine the amount of heat required for the process. It determines the amount of heat required for process. Okay. It determines the amount of heat required for process. Second point, the thermodynamics deals about direction of the process. Thermodynamics deals about direction of the process. It develops correlations between the properties of the system. It develops correlations between the properties of the system. last point, it determines the phase equilibrium and the reaction equilibrium. Determines the phase equilibrium and reaction equilibrium. Phase equilibrium and reaction equilibrium. Reaction equilibrium. Okay. What is the second point? Thermodynamics deals about the direction of the process. Who will tell? Rosie will tell. What is the meaning of this point, Rosie?
It gives a direction
Huh?
process in a step by step.
Second point, I am asking second point. This point. What is the meaning of this point? The first point we discussed. For any part, if I want to do, for example, I want to walk from here to here, how much energy I require, thermodynamics will calculate, will tell to me. Okay? Okay? So if you want to stand for half an hour, if you want to stand for half an hour, how much energy you require? The thermodynamics will calculate, give to you. Okay? So like, second point, so that's the first point. For any process or any work, how much energy you require to do particular task. Second point, thermodynamics deals with the direction of the process. What is the meaning of this? Direction of the process.
To show the directions of the process
Step
step by step.
by step.
In which direction the cost is less, it is.
Each direction cost is less. No, that's not the point.
From high to low.
Huh?
From high to low.
High to low. That direction will tell.
Yes, if it is high to low, it will require low amount of energy.
No, direction will tell.
In chemical reaction, whether it is proceeding in forward direction, like whether the reactions are not products or.
For example, yes, very good. For example, A plus B are mixing. Which product is forming? C. That's for example C. Only why C? Why not D? Sometimes D also will form. So it will tell the direction. For example, that's a, for example, it will tell, sir, for example, wood is there. Wood, you are burning the wood. CO2 will be emitted from the flames. For example, if I burn the same carbon related carbon tire, but CO carbon monoxide will be emitted more from the rather than the CO2. So this thermodynamics tell. So in this process, which one will be generated, which direction? So CO2 will be generated or CO? Because so for example, you take the wood is the same carbon only, carbon molecules only, and when you take the tile, so that is also carbon molecules only. But when you burn them, but one direction will in one reaction the CO2 is generating, another reaction the CO is generating. So with this direction will tell which one will be generated, CO or CO2. So okay, so this is the direction will tell. Okay, please. Third one, it develops the correlation between the properties, relationship between the properties, how the temperature and volume and density are related, are viscosity, how they are related, how pressure will be related. So these correlations are, it will determine. For example, if I say something bad to the Ramesh, will anyone will hurt? So that is the correlation. Okay, understood? For example, నేను రమేష్ని ఏదో తిట్టాను, ఇక్కడ ఎవరైనా హట్ అయ్యారు అనుకో ఏమవుతుందంటే దట్ కోరిలేషన్ ఉంటుంది, తను అన్నాడు నన్ను అంటే. So that is a correlation. For example, how they are related. Okay, it determines the phase equilibrium, reaction equilibrium also. Means for us as a pharmaceutical engineering, so if I want to convert the raw material into the product, where is the equilibrium is forming? Equilibrium means no reaction further take place. So where it is forming, how to avoid that? This thermodynamics will help. In the not only reaction equilibrium, phase equilibrium also. I am burning something, I am heating up something, the phase is changing from one phase to another phase, like a water to liquid, vapor phase. But somewhere after that some time, it will no more further changes because of the both are reached into the equilibrium. So how to avoid that? So that will, the description will be given by thermodynamics. So these are the 4 points. So this subject will helpful to us as a pharmaceutical engineer to develop a particular task, to know the direction of the process and to know the property correlations and to know the phase equilibrium and reaction equilibrium. Okay. So now next one, I already discussed this. So this in this pharmaceutical engineering process where our subject is fit into. Manufacturing. For example, liquid ammonia and compressor, they are sending. Okay. So they are sending through the pipe through the synthesis cover. After that, ammonia, CO2, H2 are forming, and they are going to distillation cover and flash them. This is the separation term, and after that, any impurities are there are removed. So this is the process. Okay. For example, here to know to transfer the fluids, the fluid mechanics will help you. The subject will help you. And to know for example, you want to heat up the process. For example, here you want to heat up you want to heat up this process as fluid. So you need to know the knowledge of heat transfer. How the heat transfer will take place. What are the equipments I need to use. And after that, they are formed. The material is formed. Then separation. I need to separate. Then reaction. So after the reaction is formed. So what is chemical reaction engineering? Next semester you are going to have. So the subject will tell you how to design reactors, how to design the instators, how to perform a good efficient reactions. Okay, what are the things are useful. So next, mechanical unit operation you already studied. Means for example, you want to do the filtration, otherwise before the raw materials you want to do some processing. So these are all helpful. Okay, that will tell you. So mass transfer also in the next semester you are going to have. Means after the product is formed, how the materials has separated, that is the mechanical unit operation. In that to deep, how the mass is transferring from, in that for example in filtration also, how the mass is transferring. For example, what tea, you take the tea, you are filtering the tea. Okay, tea powder is there, and in that water is there, of course the tea is formed. Now when you use the filter, the mechanical unit operation, just nothing is happening, and the tea is coming from the sieve and you can drink the tea. But some process, for example, some heating process, if you want to, this is the distillation column, is the mechanical unit operation process or mass transfer process. Means you are heating the material to want to separate the two, because in the mixture two compounds are there. You cannot separate by sieving because they are in liquid state only. One solid is there, one liquid is there. You can use a sieve methodology so that you can separate them. But both are liquids. But I want to get the pure percentage. How can I get? Means I have to heat up them up, because both are at different boiling points. One will fastly boil and convert into the vapor. So means this molecule will transfer now one place to another place. This is called mass transfer. Mass is transferring. How this mass is transferring? How to separate them effectively? That will be discussed in the mass transfer subject. So next one is the control process. Have you seen anywhere? Industry, have you visited any industry? You can see every industry, this is the heart of the thing. The control room. This is called control room. So process control system in the 4th year, that subject will help you how to control the process automatically, not manually. I know to do anything. I will sit here, I will just watch it out. Anything it's not in. For example, tank is overflowing. For example, here tank is overflowing. How to control it? I don't need to control. The tank itself has to control. How to do it? That is the process system, process control system. Okay. So now, but where is the thermodynamics? Thermodynamics is every task, you take any task, how much energy, for example, you want to do this task, how much energy I require, that will be calculated. Compressor, if you want to compress some fluids, how much energy required, that will be calculated. And also reaction, if you want to do this reaction, how much energy required. Next, if you want to separate them using the distillation column, how much energy I require, so that will be calculated. For everything, the how much energy required, it will be calculated in the thermodynamics. Okay. So this is the. So we come to now we discuss first what is the introduction to the course. Now after that we discuss the introduction to thermodynamics. What is the thermodynamics we discuss? Where it is, how it is born. So after that, So now how this subject is helpful to as a pharmaceutical engineering in the industry, pharmaceutical industry. So now we will come to the content. Unit 1, please write unit 1 content. First unit content. You have already written last class people. First unit content. Very simple terminology and we already know everything. The first law of thermodynamics, the unit 1 content is first one is the first law of thermodynamics in that types of energy, work, heat and energy changes, applications of first law of thermodynamics to different processes. First, types of energy, how many types of energies are there? What is the work? What is the heat and energy changes, and the applications of first law to different processes. Next one, under the second law of thermodynamics and its applications in that entropy. First one is the entropy, reversible and irreversible process. What is the Carnot cycle? We will discuss TS diagram, enthalpy of mixing and disorder, refrigeration and liquefaction. Completed everyone? So this is the entropy, reversible and irreversible process, Carnot cycle, TS diagram, enthalpy of mixing and disorder, refrigeration, liquefaction. Completed everyone? Okay. Refrigeration and liquefaction. So who can not answer? So maybe you. What are the different types of energy? You know already.
Wind energy.
Wind energy, very good. Solar energy, wind energy, yes, very good. Thermal energy.
Kinetic energy.
So you first one is the wind energy. Wind energy. Second one,
Solar energy.
solar energy. You are getting doubt, solar is energy or not?
What's that?
You will confirm. You confirm or doubt?
Yes.
Okay, confirm. Okay, next one.
Water energy.
Hydro energy. Now, 4 is sufficient. Next one. What else? Please. Next one. What type? 3 she told. Other. Types of energy. Good. Thermal energy, very good. Thermal energy. Mechanical energy, very good. Mechanical energy. Electrical energy, very good. Please see. Next one. Electrical. Next one. She will tell. She has not told. So what are other type? 3 somebody told. Another 3 now. Say next. Any other are there? Locomotive energy is a mechanical energy. Mechanical energy told. So, kinetic energy. What is the kinetic energy?
Internal energy.
Kinetic energy. What?
K is equals to half mv square.
Potential kinetic energy. Okay, right. Kinetic energy because of the motion. Yeah. Kinetic energy, right. She will tell. She will tell. Wait. Potential energy. Energy. What else? What else? Very good.
Nuclear energy.
Nuclear energy. Very good. Nuclear energy. Yeah, please. So you told two. Who else will tell? Pressure energy. Pressure energy also comes under kinetic energy one. What else? What else we have? Light energy. Yes, correct one. That is called electromagnetic energy or radiation. Radiation energy. Radiation or electromagnetic energy. What else?
Steam energy also.
Steam energy. Steam energy. Same. Wind energy. Wind energy. Tide. Yeah, tide energy. That's very good. Tide energy. Excellent. Who said? Who told? Gravitation energy. Correct? Who? Very good. Gravitation energy. Gravitation energy. What else? Please think. Gravitation energy. What else? Magnetic energy. Magnetic energy also comes under electromagnetic only. Electromagnetic only. What else? Electrostatic energy, electrical energy. All are same, but subcategories. What else? Think.
Thermal energy.
Thermal energy. Thermal energy?
Yes, sir.
Thermal energy. Okay? Okay. So wind energy. Wind energy.
Sir, chemical energy also.
Chemical energy. Excellent. Chemical energy. Okay. So now come to wind energy. So what is the wind energy? Wind energy means? Wind energy is the research. What is the energy? Wind energy. Wind energy. What is the wind energy? What do you call? Rotating. How? What is? See. What is the energy means? Do you know energy means? What is the energy? Some force per unit. Energy means it creates some force and displacement. More or less equal to work only. Okay. What is the wind energy? Wind energy. So wind energy is the energy created by the wind. That's it. Okay. Please next solar energy. Yes. Solar energy. So solar energy, light energy, of course. So the solar energy comes to which category according to you? Actually, these all energies are broadly classified into two: kinetic and potential. According to your opinion, the solar energy comes to potential energy or kinetic energy? Kinetic means what is the kinetic energy? Kinetic means? I'm not asking formula. What is this kinetic energy?
Because of its motion, sir.
Because of the motion. So energy is created because of the motion. Okay. So solar energy which comes to kinetic energy because of the motion. Potential energy means
Constant. Constant. It conserves energy.
Motion, sir.
It
It's
constant.
called kinetic energy.
wait. She told something. Height.
Yes, sir.
Because somebody is not in a height.
Gravitational
No.
energy.
Because of its position.
Yes, sir.
It's not height, position. Because of its position, it has some energy. Okay. So that is the potential energy. So now you know the motion, the energy created by the motion, and because of its position. So two different energies are there. Most of the energies are classified into two categories only. So this wind energy, so solar energy, according to your opinion, under which category it comes? Kinetic energy. Is it correct, kinetic energy?
Yes.
Potential energy. Can you please raise who are saying potential energy? I am not saying that you are wrong. I want to appreciate you. Very good, very good. 3 members, 4 members. Any else? Anyone else? Okay. So can you justify this? How it is the potential energy?
Basically, solar energy will come from sun also.
It is coming now.
It is light. There is not motion, no sir.
It is a motion. Photons are moving. Photons are moving. After the photons, electrons are ejected. Electrons are moving. So energy is generating. Means it is not comes with a potential. Kinetic energy. Very good. Please see. Next one, hydro power or hydro power energy. So what is the hydro power energy? Next one.
Energy comes from the water, sir.
Energy comes from the because of the motion of water. Okay, water. So it comes to which category? Potential energy, kinetic energy.
Both are helpful, sir. Both are helpful. How can I justify? If some water stored for a long time, it has potential energy.
Yes.
After the releasing of gas, it will be moving and converting to high kinetic energy and rotating blades.
Okay.
Then it will form the
Very good.
Both are helpful, sir.
No, it comes under the both category you are saying, but you cannot say they comes in the both category, but only one category it comes. Which
so
category?
primarily it was kinetic energy.
Kinetic energy. Very good. Okay. Next one, last one. Last one has not told. Which one? Next one, thermal energy. What is the thermal energy? Because of the heat. The energy is generated because of the heat. Is it the potential energy or thermal energy? Kinetic energy? Can you please justify why it is the kinetic energy? Very good. Heat చేసినప్పుడు, so means the vibration of the molecules and the heat is generated. Very good. Yeah, please see. Next one. Next one is the mechanical energy. Mechanical energy is the, what is the mechanical energy?
Energy convert from electrical to mechanical.
No, I am not asking. What is the mechanical energy?
It produces.
I am not asking engine. Engine will convert the some energy to the mechanical. What is the mechanical energy? What is the mechanical energy? Energy created from where? Mechanical means motion of the mechanical devices. Because of the motion of mechanical devices, the energy is created. So that is called mechanical energy. Is it the potential energy or kinetic energy? Which category it comes? Kinetic energy. Is it true? Why? Why? You don't know why. Why you tell? Rosie. Why Rosie? She said mechanical energy definition. What is the mechanical energy and how? She also told it comes under the category of kinetic energy. So justification point. So can you justify that how it comes under the category of kinetic energy? Kinetic energy means because of the motion. Is there any motion in the mechanical energy? You don't know because of the motion of the mechanical devices energy is generated. So motion is there. That's the reason it comes under kinetic energy. Next, electrical energy. Electrical energy. What is electrical energy?
Attraction of cations and anions.
Attraction of cations and anions is electrical energy. Electrical energy. Electrical. Wait, he also knows.
Attraction and energy.
Motion of electrons. When the electrons are moving from one place to another place, that is called electrical energy. So is it the potential or kinetic? Kinetic energy. So kinetic energy is the broad direction. Potential, okay. Internal energy. Next one. Internal energy. What is the internal energy?
Kinetic energy is potential.
Both are called internal energy. Now, internal energy. called internal energy.
Yes,
Yeah?
sir.
Who told like that? Which subject told like that?
Internal energy is equal to K plus P.
Yes, sir.
What?
U is equal to
Delta U is
K.
equal to K.
Delta, what delta?
U.
Delta U is equal to?
K.
So U means, for example, this U play, in terms of U, I will generate A also, I will not put A also. No. The kinetic energy, potential energy is not equal to the internal energy. How can you say that?
Yes, sir.
So what is the internal energy? Because of the motion and because of the position, so it has some internal energy. Somewhat is correct only. Okay. So what is the general internal energy? Internal energy. The energy which is there in the internally. Internally, that is correct. But it is internally in the form of kinetic energy, because always molecules are vibrating. And form of kinetic energy is the position. Okay. So because internal energy, how it is correct means actually energy which is there in the internally of any substance. But that how it is in the form is in the form of motion of molecules is kinetic energy and because of the position potential energy. Okay. Next one is the nuclear energy. Nuclear. Bombs. Yes, correct only. But that is the result of the nuclear energy. What is the nuclear energy? Nucleus is there, electrons are there. In the nucleus, what are the elements are there in the nucleus? Protons and neutrons. That energy. So actually, nuclear is very strong and high power energy because the neutrons and protons between the two neutrons very high repulsion energy, but one proton is there in between. Two protons have a high repulsion energy, but one neutron is there to compromise both. But when one neutron is released, so this way, because bond energy is there between two, that is converted into nuclear energy. Okay. Yes. Next, pressure energy. Next one, pressure energy. Due to the pressure. What is the pressure?
Force by area.
Force exerted by area. That is okay. Very good. That is the pressure energy. Radiation energy. Next one.
Due to the vibration of the molecules.
Radiation due to the vibration of the molecules. No. Radiation.
UV. Absorption of the energy will be
What is the radiation or what is the electromagnetic radiation? Electromagnetic radiation. The light is the electromagnetic radiation only, na? Light. That is the visible light. Invisible light, what is that? Infrared. UV light. Radio frequency, radio, and also what else? What are there? X-rays. Microwaves.
Those molecules.
These are all called.
Reflect, no, sir. That will be converted.
Pardon?
The molecules will be absorbing the energy and then they will absorb something and release. So that will cause the radiation.
That is called when the radiation is generated. This is correct. When the radiation energy is generated, or light energy is generated, or radiation energy is generated, this is correct. When some energy is absorbed and will come to the excitation energy state, from the excitation it cannot stay long time, after will come to the lower state, ground state. In that case, because high to low is coming, then the energy is released. That energy is called radiation energy. But okay, but how it is generated is correct. What is this? Okay, means so these are all electromagnetic waves are called electromagnetic energy. Very good. Next, tide energy. Next one. Tide energy. Tide.
Movement of tides.
Moving of the
Tides.
tides. Gravitation energy. Is a gravitation energy potential? Gravity is a potential energy. Is a potential energy, kinetic energy, gravitation energy. Potential energy. Why? Position. Very good. Chemical energy. Correct only. Potential energy or kinetic energy?
Potential.
Why potential? if you say something, you have to justify yourself.
Sir, when we reaction happens,
Ah.
the molecules will transfer this motion. Motion will transfer
Ah.
because of
But without any reactions occurred, is it a because of chemical energy or not? No reactions occurred. So oxygen molecule is in the air. So this oxygen molecule doesn't have any energy or not? It has. So no reaction is there. So do you call this a kinetic energy or potential energy? Huh? Potential energy. Chemical energy is a potential because of the their bond between the two molecules are because of its position. Okay. Ananya, Shriya, Shruti, Srividya, Shravya, Devi Shravya, Vardhan, sorry. Correct one, Vardhan, okay. Next, Tanusha, Shiva Pranita, Siri Chinmay, Shivani, Harshini, Yamuna, sorry.
Present, sir.
Yamuna present. Jashwant, Akila Bhavani, Srivalli, Chandana,
Absent, sir.
Satvika, Lalita, Ravanita, Praveen, Sangeeta, Snigdha, Rosie, Rahul, Teja, Bhavyasri, Vikesh, Charitasri, Sharwan, Nagendra, Lalit, Abhinesh, Archita, Ramesh, Shravani, Sanjay Kumar, Krishnaveni, Ifra, Aruna, Ishwar, Kalastri, Ram Shetty. Is boy or girl? Girl. Kalastri Ram Shetty. Girl only. Kalastri. Sri is there, okay. Okay. Sindhu Priya, you are Sindhu Priya. Shravya, so many Shravyas are there, na, in the class? Two only. Shravya? Absent. Sindhu Jyoti? Sushma? Krupa Kanti Kumar? Aishwarya? Srilata? Sushma? Roshini, okay. Rajita? Shravani? Nagasravya? Sharanya, sorry. Nagasharinya? Akila?
Absent, sir.
Soumya? Santosh Kumar? Shanti Sanjana? Sheikh Karishma? Bharadwaj? Sudishna Redya? Sudishna. Varshini Raj. Raju Raja? Raj. Varshini Raj. Pallavi? Nitin Babu. Nitin Babu. Okay, thank you.